Hello, welcome back to the channel. So let's continue our previous discussion on solution to separable differential equations, and let's solve the solution to this differential equation over here, which satisfies this initial condition given in the question. So we are doing a different variant of the separable differential equation where you are given y dash instead of dy by dx. So y dash is nothing but dy by dx. I'm sure you must be familiar with this term. This is just another representation of the derivative of y in this case. So now let's solve for this separable differential equation. But before we solve for this separable differential equation, I'll highly suggest you to first watch my previous videos in order to get the full idea about how we solve separable differential equations and what is the correct approach that we use in order to solve the differential equations of this form. So now let's write the equation first. So the equation is basically y times y dash is dy by dx, and then in the denominator you have e to the power x minus 2x, and on the right hand side you have 1 by y. So you know that for solving the separable differential equations we move the similar variables to one side. So let's keep the y variables to the left side and the x variables to the right side. So we can move this expression over to the right hand side and this y to the left hand side such that we'll get y square dy equals e to the power x minus 2x and then dx in this case, right? And now we can integrate both sides in order to get the final function. Integration of y square is y cubed by 3, and integration of the right hand side is basically e to the power x minus x square, because the integration of 2x is 2 times x square by 2, which is x square, and then you'll add the constant of integration as well, right? And since in this question you have been given the initial condition, which is y of 0 equals 3. So what it means is when your x is equal to 0, because your function is in terms of x, right? So since this is your function representation, it means when your x is equal to 0, which is this value, your y is equal to 3 in this case, right? So now let's substitute these x and y values in this equation. If we do that, 3 cube upon 3 is basically 9, because 27 by 3, and e to the power 0 is 1 minus 0 square plus the constant of integration, and then c is equal to 8 in this case. So now we got the constant of integration. We just have to calculate the final function. So for the final function, we'll substitute the value of c and we'll get the final function. So our final function would be y cubed by 3 equals e to the power x minus x squared plus 8 in this case. And now, since we are familiar with writing the solution to differential equations in the form of y equals f of x, let's do that. Let's bring this 3 to the other side such that your right hand side will be 3 e to the power x minus 3x squared plus 24, and then we can take cube root on each side. So taking cube root on each side would be cube root of y equals cube root of 3 e to the power x minus 3x squared plus 24 in this case. And this will be your final solution to the differential equation given in this question over here, which also satisfies this initial condition. And again, since you wanted to calculate or solve completely for y as a function of x, we got the final expression of y as a function of x as well. So that's it for this video. Again, the main takeaway from this video is a different notation that we use to represent dy by dx. So it doesn't matter if you see y prime or y dash or dy by dx, they are basically the same thing. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.